Hi, everybody. Welcome to tonight's conversation with epidemiologist Glenn Grossman. Today is Sunday, March 21st, 2020. So glad to be back with so many familiar faces, and welcome to new faces who are watching this after our recording session. Really so lucky to be together as we go through this journey together. Glenn Grossman is an epidemiologist with over 20 years of experience. While pursuing his doctorate in epidemiology at UNC Chapel Hill, Glenn served as an epidemiologist on staff at the UNC Infectious Disease Clinic for 2 years and taught epidemiology and advanced analytics at Duke Medical School and at UNC. He has been involved in epidemiology forecasting and advanced analytics with Bristol Myers Squibb, Sanofi, Novartis, Medicare, Medicaid, Veterans Health Administration, Military Health Service, CDC, and other programs within the United States and abroad. All views expressed today are his own. So as usual, Glenn, we like to kick it off. You give us a quick update on how things are looking in the US and abroad.
Thanks, Rebecca. Welcome, everyone. All right, let me share my screen. There it is. All right, so here's the US. Let me actually, there's better. Where am I trying to look? I'm trying to look here. All right, so the US as a whole, this is fine for now. The US as a whole is doing really a lot better now. In fact, let me switch to one other thing. Oops. All right, let's go here to CDC cases. All right, so I am looking for this curve. All right, so the US as a whole is doing better than we were. You can see that we've stopped decelerating, or we've stopped declining as fast as we had, and so it's sort of leveled off now, unfortunately. So we're still at pretty high levels. When you compare where we are now, where we're leveling off, that's roughly around the peak that we had over the summer in our second surge. So we're not out of the woods. More interesting and more worrisome is that some states are doing better than others. So when you look at this one, you can see that there are a few states in the Northeast and in the North that are really not doing well. Among them, New Jersey, Massachusetts, Rhode Island, New York. You can see that it's around New York City. It looks like a little bit in Boston too, but around New York City is where we're seeing the most of it. And this is really worrisome. When we look at New Jersey, you can see that New Jersey, whereas the United States as a whole is going down or flattening, New Jersey is actually going up. And so this is really disconcerting for people who live in New Jersey. And a lot of people in New Jersey don't realize that this is the case right now because no one's really talking about it. But this is not leveling off in New Jersey. We're on an upward peak, upward trend now. So and people have been talking about reopening restaurants and going out more. It's surprising because the weather has started to get nicer over the last week or so, that the numbers are still rising. So this is a little bit worrisome, and so we're gonna have to pay attention to this. It means that what we should be doing is putting more restrictions on what we're doing. Typically with better weather, you'd expect people to spend more time outdoors, and we know that there's a ton less spread when people are outdoors. But the fact that New Jersey is not just flat, it's the fact that we're literally going up is very disconcerting. When you compare New York City, so I'll scroll down a lot. New York City is currently the top in the nation in terms of where most of the spread is going, the outbreak. New York City is very densely populated. It's much easier to transmit it there. And so the vulnerability level is very high. It's not spreading crazy rapidly. If you recall, back in March, this time last year, the R was above 4. And so it was, I think, well, we had been shut down for maybe a week or two at this point, but right before the shutdown, or right around the time of the shutdown, it was above 5, and it was already rapidly decreasing at this point. So the fact that it's slightly above 1, remember 1, when you look at the infection rate, is this magic number. If it's above 1, then you'll have an increase. If it's below 1, then you'll have a decrease, and 1 state means it stays the same. And so because it's above 1, then that means that it's increasing, and New Jersey is above 1 as well. Let me click here. So New Jersey is at 1.07. Michigan is also quite high, 1.26. But New Jersey currently has the highest number of absolute cases, whereas Michigan, relative to the size of the population, whereas Michigan is growing at a faster speed. But when you look at New Jersey, when you look at that curve, not that one, this one, we're increasing again in New Jersey, and that's not great. When we look outside, and the other thing I'll talk about here is variants in the United States. So you can see that there are some hotspots. One of the reasons that Michigan might be doing so poorly, we just were looking at that. The Michigan was really not doing very well. One of the reasons might be these variants that are spreading there. A lot of us were expecting that given the spread in Florida, that we'd be seeing a lot more, or rather, given the spread of the variants in Florida, that we'd be seeing a lot more actual spread in terms of absolute numbers. Yet here, when you look at Florida, you can see Florida's not doing as nearly as poorly as some other states are. And part of the reason is one of the big reasons is that Florida's weather is great right now. Not too humid, not too hot. A lot of people are spending time outdoors, and it's just very comfortable. And so we think that the seasonality, the weather component of this, is a really, really important factor. But it's not the only factor, and that's why New Jersey is still spreading. So a lot of us are keeping an eye on New Jersey. When you look at some of these other variants, so California is also sticking out as a hot spot. When you look at how California is doing here, you can see that they're also doing a lot better than much of the country. See how well California is doing. California, in contrast to Florida, California hit a high peak and then shut down much of the state. And so then they got their numbers much more under control more rapidly. That could have been Florida, but Florida decided not to shut down when they hit higher numbers. And so even though they hit for a short period that higher number, they are still having a fairly large number of cases that's sort of flattening out. So they could be doing much better, even though they're doing much better than other states like New Jersey. They could be doing even more big relative to how we are doing. But a lot of it is based on the geography and stuff. All right, outside of the United States, let me point to, so Europe. When you look at Europe, some people are talking about Europe as being in their third wave now. They didn't really have a second wave in the summer that we did in the United States. And so this is really their third wave. So when you look at, let me just flip through a bunch of countries here. Let me just go to some of the big ones. Brazil, before I go into Europe, Brazil is interesting. We've been following that for a while because of the Brazil variant. The seasonality, this is not the fall winter season, which is when most of us have had the major outbreaks. And so the fact that Brazil still has so many cases, a lot of people are being reinfected there. We'll talk about that a little later tonight, about the reinfection rates that we know. But this is something a lot of us are paying attention to. Why are the cases so high? We know that herd immunity was hit, or what should have been herd immunity was hit back in November in some of the states of Brazil, and yet the numbers are still rising dramatically. There are many places where over 75, over 80% of the people have been infected the first time, and yet now look, the numbers are still rising even higher. So it's worrisome. When you look at Europe, which we'll get into a little bit more, I know that there are some questions about that. Some parts of Europe, Estonia is really leading in terms of how poor it's doing right now, unfortunately. You see the shape of the curve, it's just really not doing well. Africa is being hit a little bit harder, some countries in Africa than earlier, but let's focus on Europe for now. Finland, you can see, is going back up. France is going back up. Germany, look at how sharp that's starting to go. Greece, a lot of these countries in Europe are really hitting this, what they're calling this third wave now. Italy. So some of these countries have started to shut down. Italy, France, I think they're talking about all shutting down now. Not all countries are doing as poorly as that. You can see Netherlands is going back up. There is the weather, the geography component of it. So you'll notice that Spain is not among the ones doing the worst right now. I think Spain was a yellow. Let me just go up here for a second. Yeah, Spain, you can see Spain is doing better than some of these other countries in Europe. So geography plays a big role. Southern Europe is doing better in general. Although I think Portugal was over here. Let's see. No, Portugal is not over here. Yeah, Portugal is over here. So the geography plays a big role, which we've been talking about for months now. All right. Other than that, let me see if I hit everything I wanted to talk about. Oh, I can talk about this in terms of what we're looking at a high level. Well, I've talked about this enough, I think, in terms of the countries. We can look at a map real quickly just so we can see where things are looking. You can see that some of Europe has these really dark red spots that are not good. It shows that the rates are very high right now in some places. But so the Southern Hemisphere, it still surprises me that the Southern Hemisphere is doing so poorly right now. But this worries me because this might be our later in our year. Hopefully a lot of people will get vaccinated and we'll be able to avoid much of this, but it is very worrisome. Let me just talk about vaccination. Where are we with that? Oops. All right, so down here, I want to show this. So what share of the population has received at least one dose? So we've been looking at that a lot. Israel is around 60%. UK is going very rapidly. You can see that the slope, Israel has hit a peak, but then they're sort of leveling, they've sort of leveled off for a while. They're reaching this point. They're still trying to administer the vaccine as much, but they've hit a wall of vaccine hesitancy. Maybe not a wall, but more resistance, more vaccine resistance. And so as a result, they're not going up as fast as we'd like. UK, they have hit, they focused at first on the highest risk population for severe COVID. So that is what matters most, but still it would be nicer if they could hit a higher percentage of the population. UK, you can see that their curve is going pretty fast. And so they should catch up to Israel probably within another 3 to 4 weeks. And you can see Chile is going pretty fast as well. The United States is doing great. We are at around 24%. So that's roughly a quarter of people in the United States have had at least one dose, which is really great because you get a lot of protection just even after that first dose.
I just want to jump in to clarify. When you say a quarter of people, you mean a quarter of people 16 and over?
A quarter of all people in the United States.
Oh, so that includes children
Kids,
in this population. Okay.
So it's actually a higher
children are not yet getting vaccinated. Okay.
Exactly. It's a higher percentage when you look at the totals. Well, let me just verify that's the case. Yeah, because it's just the total population. So you're right. It's even a higher percentage among the over 65, among the over 16 and whatnot. Israel, one of the reasons, I haven't talked about this previously, one of the reasons that Israel did so well was they negotiated a deal, I think, with Pfizer, where Pfizer gave them priority for some of their vaccines if Israel shared the data with Pfizer of how of everything that was revealed in the population that came out from the vaccine. And so that worked out really well. Europe has been prioritizing one dose in many countries. So UK, they plan to do a second dose, but just because there is some protection from the first dose, they've really prioritized the first dose. So you'll see UK is around 40% have received one dose. Yet when you look at the second dose, this is how many people have been fully vaccinated. So have received the second dose, you'll see UK is down only at 3%. And much of Europe also is very, very small numbers. United States, we're at around 13%. But Israel is still very high, 52%, which is really great. And so, but you, like I said, they're sort of hitting this wall now. I don't know what that's going to look like in the next month or two, but hopefully they'll be able to vaccinate more. All right. Yeah. So this is. Let me take a snapshot of the world. Here it is. So you can see that the United States is doing really well, and Chile is doing well, and there's some other great progress that we've talked about, but that much of the world still has virtually no vaccines at all. And so we need to do a much better job of vaccinating, because as we keep on saying, this is a global pandemic. It's not just the US. The key vulnerability for all of us is going to be new variants that emerge. And if we don't vaccinate the rest of the world and it keeps on just spreading there, then that's where all the mutations are going to occur. And then new variants will emerge. And any infection that happens anywhere in the world will end up in the United States as people start traveling and whatnot, and it comes back. So, so we really need to invest in vaccinating the globe to protect not just people outside of the United States, but also us in the United States. All right, Rebecca, with that, let me open it up to...
Terrific. I'm going to turn the floor over to Harry. Let's see if I can, I'm going to ask you to unmute, please. Or actually, I can unmute you. There you go.
So my question is, what is unique happening in New York and New Jersey that is causing the increases in the rates of infection? Is it a variant that's coming out, or is it just fatigue related to the COVID situation?
That is a really good question. Let me switch. So let me open this up. All right, share. Now let me also go back here. So you can see this was oh no, this was the cases. I need the variant tracker. That's not it. That's not it. Here's this one was it. So it's interesting. Right now, the CDC is only tracking 3 variants in general that are these variants of concern.
Could you remind us what those variants are, please?
Yeah, so B117 originally came from UK. People are trying not to use the geographies anymore because it's really, and here, let me show another, let me just pause this for a second and open up a really great website that describes this. All right, I need global variants. All right, so here, so B117 was originally the UK variant, and you can see that it's not just in UK anymore. So calling it the UK variant, I know it's helpful. I know we used to call things the Spanish flu and have names for things, but it's not really, there's nothing unique about UK about this variant. It was just identified there. And the reason it was probably identified there as opposed to somewhere else was just because they had much, much more genetic screening in UK. They were way ahead of the game. So it could have easily evolved somewhere else and then just, and they found it in UK because they were just better at screening. So the B117 is UK. The B1351 was originally found in South Africa. And so it's spreading in Southern Africa, but now it's in much of the rest of the world. You can see it spread globally. And then the other one we'll talk about is P1, which is Brazil. Now there's also P2. I mean, there's thousands of variants now that are spreading. The reasons that we start focusing on a few are because these are spreading faster, or we've found that they are resistant to vaccines, and people can get reinfected with them at a higher rate. So, so those were the 3. Your question, what's unique about New Jersey and New York? So where was I? All right, so right now the CDC is primarily tracking this, so again, the UK variant, the South Africa, and the Brazil. You'll see that the UK variant is exploding at a much higher rate. So it's far, far more of this. And so when we're looking at this map, this is B117. In contrast, the South Africa variant is much less. But in New Jersey, New York, it's not totally clear. But one thing that's clear is that there are some new variants that have been identified in New York City. And so New York City, there's a couple or some that share a bunch of different similarities that we're calling the B1526 variant. So now rather than calling it a variant of concern, this is called a variant of interest. And already by mid-February, so around a month ago, it already accounted for around 27% of New York City spread, and it's increasing rapidly. So it could be the case that this variant is largely responsible for what's driving it, but it's probably not the only reason why. And when you look at the two main things that are unique about this the genome here, one is that it's the E484K, which makes it resistant to people who have been previously infected or to vaccines. And then the S477N mutation, which helps it bind more tightly to people's cells. But what that means is that it helps to replicate the virus. So it's more virulent in that sense. You end up with a higher viral load. And so B1526 is very worrisome. Currently, the CDC isn't tracking it in the same way as they are the variants of concern. But I think that this probably explains some of it. I think part of it might also be that there is vaccine hesitancy. And so not vaccine hesitancy, sorry, pandemic fatigue. And in New Jersey, a lot of us are just done with the virus. We don't want to deal with it anymore. And so maybe people are not wearing their masks as much as they should be. Maybe some people thought that they were infected a year ago, so they're safe, even though it's a year later. We'll talk about that, about the reinfection rates that we now know. And so maybe people are letting their guard down more. And so there's a bunch of things that can be at play here. We don't know the specific reasons. All we know for sure is that it's happening, and that New York City and New Jersey are outbreaks. We're not only are we not out of the woods, it's getting worse in New Jersey, New York City area.
So as a follow-up to that, Rachel, if you could unmute and ask your question, that would be great.
Sure. Hey, everyone. So I have been curious, how are the states doing that lifted their mask mandates, like Texas and some of those other states? I mean, in my perfect head, was hoping that not that I want cases to be rising, but that there was support for really wearing masks and that we would see uprisings in those states. But it doesn't, is that not what we're seeing, or?
Yeah, that's a really good question. So these are all the mandates that are currently in place. And a lot of us thought when Texas did that you're right, that we would see a spike there as well. So currently, businesses are almost all open everywhere with a few exceptions, some constraints. California, some that got hit earlier, but there's no lockdowns or anything like that. And particularly stay-at-home orders, there are some advisories still. The one outlier is Puerto Rico. But in the continental United States, Alaska, Hawaii, there's no lockdowns or anything like that. The one thing here that we're looking at is the mask mandates. It's not just Texas. A lot of states do not have any restrictions on mask wearing currently. Despite that, a lot of people in the population are still wearing masks. And so it's not necessarily the case that when they eliminated the mask mandate, that the number of people wearing masks fell a lot, because a lot of people just choose to wear the masks because they know the CDC is telling them to. However, when you look at which one? This one. So let's look at Texas. So it's not hitting Texas as much as we would have thought. And part of the reason for this is that we know that, I mean, just visually, you can look at this, the epidemic is not hitting all states equally for various reasons. One of the big ones being geography. It's just not going to be the same. We know that before anything, so back in end of February, early March of last year, before the shutdowns, there was remarkable differences in how fast the virus was spreading in different states. And so some states like Florida had a really low rate relative to other states like New York and New Jersey. New Jersey, I think, was also above 5. And so as a result, let's take New York City, for example. New York City's reproductive value was above 5. So in order to get it below 1, New York, as a New York state, had to reduce the amount of spread by 80%. Whereas if there was another state that had an R of 2, a reproductive rate of 2, then they only would have to reduce it by 50% to get it below 1. And so so the higher you are, the harder your policies have to be in order to get it down. It's not because of better governance or worse governance. It's just that the epidemic is different in the different states. And so it's sort of Some you have to have different policies that are specific to the states. So yeah, Texas, the question is, look at how fast that they were dropping. If they had kept the mandate, would they have continued dropping down even further than they are now? And that's what we would have expected. But right now, given where they are, they're still going down, but perhaps they're not going down as fast as they would have if they had kept the mask mandate.
Okay, thank you. And then I had one other question. I don't know if it's more of a clarifying question, or what I'm understanding from you is increasing the vaccination rate all over the world. Are you saying there is a correlation in controlling the creation of new variants? So the more vaccination, the less variants will spread. Can you just clarify what that link is?
Yeah, it's kind of like quicksand. So if you have quicksand and the vaccine is like quicksand, then the more people that you vaccinate, it just makes it slower to get to have people get infected and then have mutations that arise. So for instance, in UK, because they're vaccinating so many people, the infections are dramatically dropping. And so if less people are getting infected, then there's less of an opportunity for mutations to occur, because mutations are just like rolling dice. And so the more people that are infected, just by the sheer number of times you're rolling the dice, the more likely that mutations can occur. So if you stop the number of times the dice are rolling, then you really dramatically decrease the number of mutations. All right, Rebecca.
Okay, great. Thanks. Great questions, everybody. Keep them coming. All right, so you touched upon the reinfection rate a little bit earlier. So the question is, if someone was infected a year ago, what is their likelihood of being infected again? And what if they were or have been vaccinated?
Yeah, this is a really good question. Let me see if I can open this up. Oh, that's not what I want. Okay. AZ, that's not it. Reinfection. All right, here we are. All right, so there have been a bunch of studies that have been looking at this over time. We still don't have a great sense that this is the one of the longest durations that I've seen so far. And what this study was, this was looking in Denmark at and they were comparing people who were infected in the first surge and then looking at people who were infected in the second surge. And because they have a national healthcare system or healthcare data set, they made it very easy to do these comparisons. And what they found is they looked among people who had a positive PCR test in the first surge, and then what percentage of them also had a positive PCR test in the second surge relative to people who did not have a positive one in the first surge. And so they're essentially the reinfection rate. And what they found, let me make this bigger, was that in general, overall, around 79% of people, there was protection. So among people who were initially infected in the first wave, around 79% were protected in the second wave. And so let's say 21%. Now the question is, how do we interpret this? Because it's easier to think of it in months. The way I'm thinking about it is that if we take the middle point of the first surge, so let me make this, so here's the first surge was here. If the middle point was like around here, let's say week 17 of all the people who were infected, this was the test rate. So you're gonna have a lot more positive tests. Even though there's less total cases, you're gonna have more positive tests. If we say the average was around in the middle, right over here, and the second surge, the average was also in the middle, like right around here, then on average, it was around 30, 31 weeks in between the middle of the first surge and the middle of the second surge. So that's around 7 months. So I'm interpreting this data to be around 7 months. And so if we interpret it as 7 months, then that means that after 7 months, around 21% of people can get reinfected. And so this is not too different than what we had known earlier at 6 months, 5 to 6 months, that 20% could be reinfected. So it's not clear. I really wish they'd looked at the outliers. So people, and they did a little bit here, but not sufficiently to answer my question. They were looking at people who had less than 6 months follow-up versus people over 7 months follow-up. but there were not a lot of people here, and it didn't really answer what I was looking for enough. I would have liked it broken out a little bit more. But anyway, the other key thing here, so this is still really good news. At 7 months, we're seeing only 21% reinfected. That's still a very large number, because you think about it, if there's like a 1 in 5, 1 in 4 chance that people can get reinfected after 7 months, that's still pretty high, particularly now that we're like a year later. But there is one thing that is more disconcerting that I wanted to point out. And when you look at people over the age of 65, they are only 47% protected. So 53% of people who were infected in the first surge could be infected in the second surge, 53%. So that's a really, really high reinfection rate among people over 65 who were naturally infected. So now the worry is, here is the rate of natural infection in the United States. And so you can see that among people over the age of 65, this is, it's like 10, 15% we're talking about. Or 15% or so. And so when you're looking at the numbers, there's still a fairly large percentage of people who are now potentially at risk to be reinfected. And now it's a year later from the first surge. And we know that the persistence has been declining over time. So it's probably even worse. The ages, when you look at this graph, I think I showed this last week, you can see that in terms of the people that were infected, kids tend to be infected the least. So the 0 to 5-year-olds are down here, 6 to 13-year-olds are over here, and the ones that are the highest are the 25, the 18 to 54-year-olds, essentially, are these highest buckets. And then the ones over the age of 65 are the red ones in between over here. And so when you look at them, you can see that it's sort of, the rates are consistent. So this is it over time, and then this is it just as the total over the last year. But now when you look at the number of people vaccinated, it's a very different distribution, because we focused on the over 65 and people with pre-existing conditions, and pre-existing conditions tend to be more common in people 50 to 64 and maybe over 40. You see that the age distribution has changed a lot. And so what this means is roughly 50% of people who have been vaccinated are over the age of 65 in the United States now. And so we don't know for sure if the vaccine reinfection rate persistence is going to be the same as the natural infection rate yet. It may be or it may not be. We don't know yet. There's a chance that it could persist longer. But the worry is, if it persists at the same rate as natural infection, then based on the weighted average, then that means potentially, based on this age distribution, potentially 36% can be infected again, even after they were previously infected or previously vaccinated at 7 months after the initial infection or the initial vaccination. Again, the vaccination, we still don't know for sure, but this is something that we're tracking. So this is what we know for now. That's all we know. Let me see. Was there one more thing here? No, that was all I have here. So this is as much as we know for now. We do know that they are working on booster shots. And so if this is a concern, then by 5-6 months from now, that's good, or from when the people are getting their first vaccines, that's already going to be the end of summer, early fall. At that point, we expect that the level of the spread is going to be quite low. Back in August, it was pretty low. In early September, it was pretty low around the United States in general. We expect it's going to be much, much lower this year. So even if there is a chance of reinfection, because we expect so much less spread, it's really not going to be very problematic. And then if we all get booster shots at that point, or as we need it, then that will satisfy any worry we might have. It would just probably be some sort of booster shot that would presumably be much easier to get, because it would only be a single dose, and the amount of logistical improvement, the learning curve, it's improved so much that it's going to be a very different place. All right, Rebecca.
This is really helpful, Glenn. This really shows us quite clearly where we are and perhaps where we're going. And Rachel has a question about reinfections.
All right, I'm all full of questions tonight. Are the reinfections, do we know anything about the characteristics of the reinfection? Are they as serious as first, worse, better, not as bad?
That's
What
a
do we
really
know
good
on them?
Yeah, that's a really, really good point. So for the most part, as far as we can tell, the majority of reinfections tend to be asymptomatic or very minor symptoms. And so the vaccines are working. The people who are reinfected, they tend to be, we know for sure that the the protection from getting reinfected goes away much, much faster than the protection we have from having severe disease. So our bodies have this memory of the virus, and so we have these antibodies, and because we have this immunological memory, it's much faster to create new antibodies and get the T cells out to fight the infection. So we can really prevent the severe disease, but it's hard to prevent reinfection. The reason that I make this distinction is because it seems like, well, all we really care about is severe infection, and that's the case. The difference is that when we talk about herd immunity, if people can get reinfected and still spread it, then that means that herd immunity is likely to be impossible. And it means that everyone will probably eventually get infected or vaccinated. And so what that means is people who are immunocompromised, if they have cancer or for other reasons can't get the vaccine, we're really going to have to protect them in other ways. There are clinical trials that are looking at those folks in particular. So we've had the monoclonal antibodies that have been out for a while. Now they're making this sort of next generation monoclonal antibodies that are long acting, and some of them might even be able to last as long as a year. So instead of a vaccine that you'd inject and have people develop their own antibodies, in this case, you'd give them an infusion of cloned antibodies that potentially would stay in their body for a year to give them protection without engaging their own immune system, which would be exciting. Okay, Rebecca.
Wow, that's really terrific news. I guess more to come on that front. Okay, so let's jump back to the international viewpoint. Last week we spoke about Astra Zeneca and the concern that perhaps this vaccine could cause deep vein thrombosis or other blood clots. And you mentioned a bunch of countries that halted delivery of this vaccine while this was being evaluated. Do you have an update? And it looks like you do.
I do, yeah, for sure. So the European Medicines Agency is similar to the US FDA. And I really think the Europe messed up here. So basically, here's what happened. They had ultimately, let me see, is this the first one I wanted to look at? So ultimately, I'll use this one. There were 469 reports of blood clots, which sounds like a lot, but it's actually less than they were expecting, because in the normal population, blood clots are extremely common. They cause deep vein thrombosis, they cause strokes, they cause all sorts of problems. And so they're actually very common. So they were comparing the 469 out of 20 million and compared that to the general population of the number of people who had blood clots in the general population matched to the comorbidities and the age and that kind of stuff. And what they found was that there was no difference with the vaccine. The vaccine is not problematic. There is no problem with the vaccine. The one exception is they found 7 cases of a type of disorder called DIC, disseminated intravascular coagulation, and 18 cases of CVST. These are the diseases. DIC causes blood clots in multiple blood vessels at once, and CVST, cerebral venous sinus thrombosis, is also both of these are very rare. This one causes clots that are found in vessels draining blood from the brain. Both of these are very, very rare. What they found is that there were 7 cases of the DIC, 18 cases of the CVST. The reason that it's important is because they were expecting to find only 1 case in each of those. If it were just the general population, they would have expected 1 case of CVST and less than 1 case of DIC. And the fact that they found so many, so 7 and 18, means that there might be something going on. We don't know for sure, but again, it's extremely rare. This is the number out of 20 million. What we do know for sure is that COVID causes blood clots. And COVID is deadly, puts lots of people in the hospital, gives them maybe as many as 10% of people have ongoing symptoms that might last for months, if not longer. And so the European Medicines Agency firmly came down and said any possible risk of the vaccine is far, far outweighed by the known risk associated with COVID in terms of morbidity and mortality. And so this is something that they might be following. But I mean, the fact that this is such a rare thing, it's not even something that, it's more like a academic interest. Like, oh, academically it's interesting, but as a vaccine, it's not something that's really anyone should be caring about. The problem now is because they halted the vaccine in so many countries in Europe, Europeans are terrified now. And so a lot of Europeans no longer want to get vaccinated. In France, we talk about vaccine hesitancy in the United States. In France, a recent survey just indicated that now 80% of people in France do not want to take the vaccine for COVID. That's insane. In the United States, we were talking about what, maybe 30% of people not wanting to take it. In France, up to 80% don't want to take the vaccine now. So what are they going to do? This is a crisis there. And so now a lot of people around Europe are very hesitant because they're spooked. And so I don't know what they're going to do now because it's a mess over there. So
well, what's going on with the distribution of the other types of vaccines in Europe? Might they be more willing to take Moderna or Pfizer or the J&J vaccine?
That's,
I could get there.
That's a really good question. And that's sort of like the second half of a question that someone asked this week about Trump. Can we jump into that? And then I can use that as the segue?
Sure.
All right. So let's do that one. If you can ask it. I forget.
Got it. Sorry. I'm a little slow today. Okay. So this is a question from the audience. What percentage of COVID deaths could have been prevented if we had perhaps a different president prior to our new administration? And how much of a difference did the US policy make versus the EU and the other G7 advanced countries?
Yeah, so it's a really good question. So I'll spend just a few minutes going into this, not too long. But so there was a big study just published in the Lancet. It's a little dated at this point. It was a little over a month ago, 5-6 weeks ago. It was part of a larger article looking at lots of health implications in the Trump presidency. But one of the things that they touched upon was looking at what percentage of COVID deaths could have been prevented. And what they did was they compared the United States to the G7, which is a fair way of comparing a lot of health things in general, just looking at the average. And what they found was that based on the average, and the G7 countries are Italy, UK, US, France, Germany, Canada, and Japan. And so when you look at these average of these countries, what they found was that the United States ended up having 40% more deaths than the average. And so what that looks like here is this is where we are. So the United States ended up having a lot more deaths on average than Europe. There was variation. That's why when we looked at the slide I was just showing here, you see that UK ended up having higher as a percentage. Italy had higher than the United States as well. But in the United States, there were states that had higher and states that had less because it was the average. So it's more interesting to look at the averages. When you look at the average of the G7 versus US had around 40% more deaths. Then the other question is, well, how does this compare with the economy? Our economy was largely due to other things, like we had more of a stimulus earlier on than Europe did, and so that had an impact. So our economy, although we had a recession, it was worse in some of these other countries. So that's part of the question, but it's not the only answer to the question because the epidemic is still ongoing. And so the next answer to the question is the vaccine rollout. And so this is really one of the things that Trump did really well. And so Trump, if you recall, had Operation Warp Speed, which was to get the vaccines out. So I wish he had done the other things well too. The 40% deaths are now locked in. Even if we had the best vaccine rollout in the world, which we almost did essentially, other than Israel and a couple other small countries, we did great with the vaccine rollout, but we didn't do great earlier on. The reason that we did so well was for 3 or 4 reasons. One, we invested $10 billion early on in the vaccine programs. We just gave money away. Even if the vaccines failed, we didn't care. We bet in multiple different vaccine companies and multiple different methods and types of vaccines. And so we just put our money in a lot of different areas, hoping that something would be successful. In contrast, Europe was slower and they didn't invest as much. They invested a little bit. So for instance, Germany invested in Pfizer and whatnot, but not nearly as much as we did. Then when they decided to purchase vaccines together in one big pot, it wasn't as large a number. It was a lot smaller. So their budget was less. The other thing was that, so the United States was much, much more liberal, because Europe is really being much more conservative here. The United States, some of the other things that they did is they waived, even though we spent so much money investing in these vaccines, these were American tax dollars that that essentially did the research and funded the clinical trials. We waived all rights to intellectual property. So that means that the vaccine companies could get all the profit themselves, which was this was with American taxpayer money. So typically you would think a lot of conservatives might be upset about this. In Europe, they didn't want to do that. They said in Europe, this is European taxpayer money, and they refused to waive that. They also, in the United States, we also waive liability. So if we find out that the vaccines cause a problem, we know after the clinical trials that they are safe and effective. But if we found out that they were not safe for some reason, then we waive the liability from the vaccine companies. So we essentially eliminated the risk from all these pharmaceutical companies to do this research. And so this was huge. The other thing was that, let's see what this was. Oh, that Trump also used some of the wartime procurement powers to secure raw materials for the companies. I've complained previously that Trump didn't use it enough. He really could have expanded more of the manufacturing capacity in the same way that Biden did after Biden was elected. But be that as it may, Trump was really good in using it to secure more raw materials. Europe didn't do that. And so as a result, if you remember, around a year ago, we had this very conversation, how long would it take for the vaccines to be launched? And we talked previously that it took maybe a decade, that it could take a long time. And back then we were saying we'd be lucky if we really shrunk everything to be able to get it by August of this year. And now we got it so many months earlier. We did a really effective job. When you look here, this is the list of the vaccines that we ended up investing in for the American tax dollars for Operation Warp Speed. We invested in J&J, which has now been launched, Astra Zeneca, which is launched outside of the United States, but the clinical trials are not done yet in the United States. We Operation Warp Speed, American tax dollars paid for that. Moderna, Novavax, which also has not been approved yet. Merck, which failed, and so that's off the list. And Sanofi GlaxoSmithKline, which also failed. I think they're redoing it, and so they might launch later this year. But the original clinical trials did not generate an immune response. So some of them worked, some of them didn't, and you can see because we had this really diversified approach, it was successful. You'll notice Pfizer was not on this list. Germany invested in Pfizer and others, and so Pfizer was quick to launch as well. But we Operation Warp Speed. The funding for Operation Warp Speed came from the CARES Act that was passed by Congress in March of almost a week to the year from where we are right now was when the CARES Act was passed, and part of what Congress paid for was specifically for this to really generate this. So if there had been another president in office, hopefully they also would have done something similar to Operation Warp Speed. And would have done it. But Trump was the person in office and he did it. So he should get credit. And so that's where we are. But let me just go back to this for just a few more minutes. The other thing that we did in the United States is we were a little bit more flexible in the rules. So for instance, we made it clear that people over the age of 65 needed to get the vaccine, or maybe people with comorbidities. But if people showed up at the vaccine sites and didn't have the comorbidity or didn't have the age, we typically didn't turn them away. And that was part of the policy. We didn't do background checks or anything, because logistically that would have complicated things a lot. And so as a result, even though there are probably more people here getting vaccinated who don't really need it because they're not as high risk, it simplified it logistically tremendously. And so in Europe, there was virtually no flexibility. And so, for instance, there was a huge scandal because one person showed up at one site for his father to get the father vaccinated, and it turned out there was an extra vaccine dose that would have gone bad. And so the people doing administering the vaccines said, well, as long as you're here, I can just give you the vaccine shot too. And this was a major scandal. I forget exactly where it was, Denmark or something. I forget exactly where it was, but maybe it was Belgium. And so it was problematic. And so because of that, it's much more logistically complicated in Europe to administer this vaccines. And that's one of the main reasons it's slowing it down so much. So that might be a big advantage in the United States. Some people are like, oh, people are cutting the line. But in the other way of looking at the flip side of the coin is that because we've simplified things logistically, it enables us to roll it out much faster, which is not, I know in some people over the age of 65 in Europe, if they try to get the vaccine now, there are no appointments available until the end of May in multiple places in Europe. And that's terrible. And there's a bunch of reasons for that, but one of these are the logistical components to it, for doing the background checks, making sure people have comorbidities, the whole thing. Just two more things, then we can go on to the next question. At the current pace we're going in the United States, we're on target based on the pace that we're at to hit 90% vaccination rate by the end of July. Now, like I pointed out with Israel, we're going to come up against vaccine hesitancy. The clinical trials have not been completed in kids yet, so the kids can't get vaccinated yet. But at the rate we're going, we're at a really good rate right now. In contrast, when you look at the G7, UK is doing really great with the first dose. These are the ones who have had the first dose. But you see that Europe as a whole is going at a much slower rate. And that's just terrible. They failed here to the same degree that we might have failed last year in terms of not shutting down, and we saw that our rates were so much higher. Now Europe is failing because United States is going to plateau more and more. We're flattening out, and we're going to reach our total number of cumulative deaths once the vast majority get vaccinated, and it's really not going to be as big an issue here anymore. But Europe, their curve is going to continue to grow for a while, and their economy is going to continue to get battered, because the only way to stop it at the pace that it's going is to continue having more shutdowns as they're needed. So really, they're really messing up here, and it's very unfortunate. But so I don't know if when we compare it, if Trump did better or not, it's a complicated story here. Europe failed or is failing now, even though their total number of deaths is much less. The story is not over, and their vaccination game is really not where they need to be. I took Canada. I heard Canada come up. Canada is in a similar boat. You see where Canada is in their vaccination rollout. They didn't purchase enough. One of the obstacles that Canada had is because they're not part of the United States or part of Europe. The United States used its massive power to really bully. I don't know if bully is the right word, but we really leveraged our power to gain access to the vaccines earlier. We invested more money, the tens of billions of dollars, to gain access earlier. We put contracts in place. Europe also, they were later to the game, but they also pooled their resources as a European Union bloc and were able to then negotiate sooner and negotiate more. Canada and other countries, I don't know if they have the same privilege as a result. And so Canada also is not doing nearly as well. And one of the reasons may be, in addition to the logistical component I just talked about, one of the reasons might be there just might not be as much supply there because they didn't really strong arm their way into it as much. It was almost a zero-sum game in some ways, as opposed to kumbaya in terms of getting this done.
Well, thank you for that deep dive, Glenn. Very helpful. I think that is the first time we've heard kumbaya on this webinar. So we'll take it. We always like a bit of good news or a bit of happy talk. Excellent. Okay, well, we're just about at the top of the hour together, and maybe we can wrap up by looking at, we've been talking a lot about adults. Can we jump to talking about children and the CDC guidelines this week, shifting the recommended distance between children and schools from 6 feet to 3 feet? And what are the implications of that? And can you give us a little bit more background into that decision making?
That is a really good question. And let me see if I can find it really fast. New York City, Astra Zeneca. Oh, where did it go? I just had it. All right, let me just make these a little bit bigger. All right, here it is. All right, 3 to 6 feet. Okay, so this is the newest thing that's come up with kids. So there was a study that was just looking at kids. And right now the common guidance has been that we should restrict physical distance to 6 feet, that we need to have it at least 6 feet away in order for it to be safe. But what they were looking at in kids, we know that kids tend to be less infectious. And so they said, well, what if we were to restrict it not for 6 feet, but for 3 feet? What would the impact be on spread among kids and spread among staff and teachers, among elementary school students? And what they found was that when you look at kids, yellow was 6 feet, orange was 3 feet. That means there was virtually no difference in 3 feet versus 6 feet among the kids. And then also among the faculty and staff, the blue was 3 feet, the gray was 6 feet, virtually no difference in spread among the faculty or staff. So which means this is really strong evidence that 3 feet is probably sufficient. And this also means that the most important takeaway here is that you can put more kids in a class. Because if you had to keep them 6 feet away when they're in person, then that means you only have a limited amount of space to put the kids in. But if 3 feet has the same protective effect as 6 feet, and by the way, this assumes that they're wearing their masks, they're doing everything else that they should be doing. But if they keep those masks on and they're doing everything else, then if 3 feet is every bit as good as 6 feet, then now you can put maybe twice as many kids back into the classroom. So this is great news for a lot of people. The one other thing here is, so just in general, I like to bring this up. This was the community spread, the rate of spread in the communities during the time of this study. This was the rate of spread of the infection in the faculty and staff in the in-person student teaching, and this was the rate of spread in students in the in-classroom environment. So you can see, and I like to put this point home again, you can see that students who go in person are at dramatically lower risk than if they were home, because people who, the ones who are getting the in-home learning, the students who are getting in-home learning tend to have the same rate as the community. And so the kids are actually better off going for in-person learning, as long as they do the 3 feet physical distancing, the mask wearing, everything else that they should be doing. All right, Rebecca.
Excellent, Glenn, thank you. Very, very helpful as always. So I guess I'm going to give a little teaser to next week. We had a very interesting question about pets and cats and dogs. So let's save this one for next week. Wondering if our pets are susceptible to COVID-19, and if so, should they be wearing masks? We'll cover this next week, along with lots of other topics. Keep sending in your questions. They're so helpful. As you see, Glenn does a lot of preparation for our discussions every week. So Glenn, thank you as always for all that you've done and answering our questions on the spot to boot. We really appreciate it. Everybody, be healthy, be safe, be well. I'm looking forward to seeing you same time, same place next week. Have a good week.
Thanks, everyone. Thanks, Rebecca. Thanks, everyone. Have a great week.